Hello, students. I welcome you all. I hope you have gone through the previous session of the chapter Sound. And today we are going to talk about speed of sound. So let me just quickly begin the session. Okay, so we have already discussed that sound is a mechanical wave, right? We talked about that how it needs medium and different type of medium, different types of medium actually, uh, you know, like make sure that how the sound is going to be. Is it going to travel faster or slower? So we know that in solids, the sound travels fastest, and in gases, it travels the slowest, and liquid, the speed is moderate. Okay. If we talk about the material properties, so if the material is denser, the sound travels less, it is slower. Okay. It travels slower. But if elasticity is more, the sound travels faster. And lastly, environmental factors we discussed about, temperature and all, that how temperature affects sound. Okay. So we know that if temperature increases, the sound or the particle will increase, right? Vibrating. And then that's how the sound will travel faster. Okay. How do we calculate it? So the basic formula is given, but later we will discuss the advanced formula. So if we talk about the basic formula, it is just similar to the speed is equals to distance upon time, what we have been studying for the chapter motion and all. Okay. So here the instead of speed, there is velocity. That means it is a vector quantity. That means your sound has direction. Okay. So this is velocity is equals to distance traveled by the sound and time taken. Okay, now the greater elasticity means the sound will be faster. And like I told you, greater density means the sound will be traveled if elasticity remains constant. Okay, if you are not changing the elasticity. Okay, now speed of sound in different mediums. We have already discussed this in our, previous class, that the speed of sound in air at around, 20 degrees Celsius would be 343 meter per second. For water, it is 1500 meter per second. And for steel, it is the maximum, that is 5000 meter per second. Now in vacuum, the sound cannot travel because there is no particle, no medium to travel. Okay, sound travel fastest in solid, slower in liquid, slowest in gases, and not at all in vacuum. So we know that. Now, speed of sound in air. So at 0 degrees Celsius, the sound speed is around 331 around. Okay. Not exactly, but around 331 meter per second. Okay. And it increases with the temperature. So every 1 degree increase plus 1 degree increase, actually what it does is there is 0.6, with every temperature, you can say 1 degree increase in the temperature, there is increase of around 0.6. Okay. So what you will do is basically you can apply a formula to calculate the speed of the sound. You can take V and you will take the original speed of the sound, which is at 0 degrees Celsius, and whatever temperature you are going to calculate it, you will multiply it by 0.6. Okay. So suppose at, 30 degrees here, if we are calculating, so it will come around as 349 meter per second. Now, what you can do is you can basically try for, let's say, let's take the, sorry, let me just erase this. Okay. You will take the speed of the sound at 0 degrees. Then you will add it to 0.6 and multiply that by the temperature. Okay. What temperature? I'll tell you the temperature you will keep here is 20 degrees. Okay. And then you can calculate the speed of the sound and let me know in the comment section. I think it is a very easy calculation. You will be able to do that. Okay. So let's see whether you are able to answer it or not. Okay. Now, why medium matters, we have already discussed that solid particles are very closely, bonded, packly arranged in a, one second, yeah, packly arranged, in this kind of form, very closely arranged and with a having of strong attraction in between them. Okay, force of attraction between them, you can say. So solids, they have the fastest transmission. Now, as the particles move further, there is lesser and lesser vibration being passed or the vibration being passed very slowly to each particle, and that's why the speed gets slower. And vacuum, again and again I'm telling you that in outer space there is no particle, so there is nowhere you will see sound being traveling or travel or moving there. I mean, there are no particles to take it. There is no medium to carry it somewhere. Okay, so that's why you won't be able to hear sound in outer space. Now, if talk about real life application, we have talked about sonar, right? We have talked about ultrasounds. Now, seismology. Seismology is the study of the earthquakes. So the earthquake waves, how they are traveling, at what speed they are traveling through different earth layers like this, right? These layers. So how it is traveling, okay, all this is being measured with the help of the knowledge of sound. And weather studies also. So the weather studies, what happens is basically uses sound speed in air to calculate or measure atmospheric temperature profile, what the temperature is going to be. So that's how it is measured. Okay. Now, you know that light actually travels very, very fast. Okay. Within a blink of a second, you can say, like blink of your eye, you can say this light is traveling, right? So it travels around 30 crores meter per second speed. Okay. But sound travels only 343 meter per second speed. That's why sometimes you will be able to see lightning before thunder. Okay. So lightning before thunder is happening because light is so fast in speed that it will reach your eyes quickly within an instant. Okay, but thunder or the sound will take a little bit time to reach you. You reach your ears. Okay. So there is a fun fact. This is not the direct calculation way, but what you can do is you can count okay, for example, lightning occurred. Okay. And after that, you are hearing the thunder sound. Okay. So in between these two, whatever, how many seconds you have seen the difference, like after lightning, let's say 3 seconds were the difference when the thunder occurred. So what you can do is you can take the 3 seconds divided by 3 and you will get how much, approximately how much far this storm was happening, okay, or lightning was happening. So around 1 kilometer far away from you. Okay, so that is how you can calculate it, but this is not the accurate way. This is just a fun way in which you are not getting the accurate details, but somewhere precise or close to the real detail. So you can tell your friends about this fun fact, okay, and they'll be amazed that you can calculate the distance of lightning. Okay. Now, the sound on moon also is not, there is no medium, like I told you, no atmosphere whatsoever, no, air or wind is there. So that's why there is no sound at all on moon. Okay. Now, let's do some questions. Okay. So in which medium does sound travel the fastest? Again, this type of questions we have done, in our previous session. So you'll be able to answer this. At 0 degrees Celsius, speed of sound in air is around 300 meter per second, 331 meter per second, 343 meter per second, and 360 meter per second. So this you have to answer. And lastly, what happens to sound speed when air temperature rises? Is it increases, it is decreases, or is it like does it remain constant or stops completely? So it is talking about the sound speed when air temperature rises. So that you have to tell. Okay. Okay. Now we talked about the medium dependency. We have discussed that earlier also. We talked about the mathematical relationship. Okay, just ignore this one because we haven't gone through this. This we'll do in our sessions. Okay. This one we'll do in our session. So far, like for now, I'm just, cutting it down. Okay. So we talked about elasticity and density, right? We talked about hierarchy, that how the sound travel, fastest in solids and slowest in gases, and also some applications we have seen. So this chapter is very, very interesting. Okay. In classes, we'll talk about a lot in depth. Okay. So if you have any doubt related to, this chapter itself, or any, previous classes which I have taken, you can contact me through my OpenPro profile. And until then, take care. Bye bye.